Hey guys, welcome back to our channel Get Please Soon. In this video, we're going to learn a new scheduling algorithm, that is round robin scheduling algorithm. This is the 18th video in the series of operating system. So if you haven't watched my previous videos yet, make sure you watch them. So the last scheduling algorithm we learned was first come first serve. So now we are going to see round robin scheduling algorithm. Getting started with today's video, round robin scheduling algorithm is simply and widely used scheduling algorithm. Now let's see how round robin works. Let's understand how simple it is, why it is widely used, right? So round robin is preemptive and time sharing scheduling algorithm. First, let's recall the word preemptive. Preemptive means it can interrupt process. Non-preemptive means it cannot interrupt running process. For example, P1 is executing. Suddenly P2 comes with more priority. Now you have two options here. If P1 stops its execution in middle and continues with P2, if that option is available, that is known as preemptive scheduling. Or else there is another option where you cannot stop the running P1. You have to wait until P1 gets completed, or you have to wait until P1 voluntarily stops itself for some reason. So if you cannot interrupt the running P1, then it is known as non-preemptive. Now here round robin is a preemptive scheduling where you can interrupt the running P1, complete P2 and then again go back to the P1 and continue its execution. This process is known as preemptive. Now round robin is a preemptive scheduling algorithm. Now we have one more term, time sharing. Let's understand that. Time sharing is nothing but the process have this chance of sharing the computer CPU time equally by dividing. So each of the process will get equal time and their turn to use the CPU. That is known as time sharing. So round robin is a preemptive and time sharing algorithm. Together, like a summary, I'm going to tell you. It means it switches between process at regular intervals. That means CPU time is divided, right? So at regular intervals, each process will get a fair chance, regardless of whether the current process has completed its execution or not. So we are not seeing if the process completed its execution. Even though if it is not completed at that particular interval, we are going to shift to the next process. That is known as preemptive scheduling. So I hope you understood the preemptive time sharing part. If you do not understand, make sure you comment below. Now, let's see how round robin works. So, I already told you that it is a time sharing algorithm. There's particular regular interval. So, that term is known as in round robin time quantum or time slice. So, time quantum is a maximum amount of time each process is allowed before getting interrupted. So, for example, if I say we have three processes here P1, P2, and P3. So, if I give the time quantum as 3 units, then P1 will execute for 3 units of time. Then no matter if the execution is completed or not, it is preemptive, it is going to shift to P2. After 3 units of time, no matter again it's completed or not, it is going to shift to P3. So this is how the round robin works. Also, the round robin comes in the circular queue. So all the process will be waiting in the circular queue. You know how circular queue works, right? So for example, this is the process P1. And once the process P1 completes its execution, if it is completed, it can go. If it is not completed, it has to go and will be standing at the end of the queue. That is the concept of circular queue. Circular queue means the front is connected to the rear. I hope you understand. The front is connected to the rear, which means the starting point of the queue is connected to the end of the queue. So if the process is not completed, it has to come again to complete its task. If you didn't understand what it is, let me explain you here. So for example, this is the queue. The first process is going for execution. And in the particular time quantum given, if it is completed its execution, then the first process will be terminated. Only the next three process will be there in the queue. For example, if in the given time quantum this process is not completed, then this process will go and stand at the end of the queue. So after process 2, process 3 and process 4, again this P1 which is standing here will get this chance. So this is the concept of circular queue where the front and the rear are connected. I hope you understood how this round robin works. So if you have any doubts, make sure you comment below. Okay, now that you understood the round robin, let's discuss few more important points on round robin. As you already know, the best advantage is very simplicity and most importantly the fairness. So here you can see at every regular interval, other processes are also getting chance. So that is properly fair because even though it is prior, which means all the process at particular regular intervals are getting a chance. That's why round robin is a very fair and very simply executed algorithm. Now, here you can see every process gets equal share of CPU time. So when I say equal share, what it is? It means the time quantum value for each process will be same. In the ready queue, how many ever processes are there? Each process has the same time quantum. If I say the time quantum is 3 units, then it will be the same for entire processes, right? Also, if there are long running and short running processes, mix it together. For example, there is a queue where you have four processes. You have two processes are long running process and two process short running process. Now you might get confusion. What is long process, short process when the time quantum is same? The time quantum is same, but for example, there are few processes which are less than time quantum, and there are few processes which are greater than time quantum, and there are so many processes mixed together. It is not very efficient algorithm. Don't worry, for this case problems we are going to solve in the upcoming videos. You will get to know what is long running and short running process because we are going to solve each of them. So please stay tuned. So this is not very efficient when different types of processes are mixed together in the queue. Moving ahead. As I already said, the time quantum is the major important parameter in round robin scheduling because everything, the Gantt chart, how the processes are shifting, everything depends on time quantum. Here, if the time quantum value, we're talking about the time quantum value, not the burst time of the processes. Okay. If the time quantum value is extremely short, like for say there are 10 processes and you have 1 millisecond time quantum, then you there will be more context switches. There will be 10 context switches, right? Which leads to overhead. Or else, if the time quantum is too long, then the scheduler may not be responsive to the changes because it takes a lot of time. The scheduler might not be attentive in the whole process, right? So this is the one thing. If it is too short or too long, or else it is a very good algorithm. So that's it from my side. I hope you understood the concept round robin well. In the upcoming videos, we're going to solve a lot of problems on this round robin scheduling. So please stay tuned. Also, if you have any doubts, I'm always there in the comments. Also, if you find this video helpful, make sure you like, share, and subscribe to our channel. Get this soon. Thank you so much for watching till the end. Bye bye.